The purpose of this experiment is to test the impact of infill pattern of a 3D printed part on flexural stress with a 3-point bending test. We will be using a Tenius-Olson tester to conduct the 3-point bending test. The tester will exert a downward force on the center of a beam with 2 roller supports on either end. The test for each specimen will run until failure. The personal protective equipment required is safety glasses and closed-toed shoes.
The variables being measured in this experiment include the length, width, and height of each of the specimens. These values are expected to be 5.75 inches, 1.5 inches, and 0.5 inches, respectively. In addition, flexural strength, which is the stress at failure and bending of each specimen, is measured. We expect this value to fall between 12 and 38 megapascals. The force applied by the Tenius-Olson device is expected to fall between 500 and 1500 newtons.
We expect the gyroid and triangle's infill patterns to have a greater flexural strength. The gyroid will have less stress concentrations because it doesn't have sharp corners. Triangles have rigid side lengths and uniform force distribution when loaded. They both have high strength to weight ratios.
In this experiment, we will be implementing several topics we covered during class. We will use the student's t-test for each of the samples because there are only 5 samples. We'll use the central limit theorem to ensure that our data is Gaussian and we can use statistics to analyze it. We'll use the chi-squared test to prove that our data is Gaussian, and we will use a hypothesis test to compare our data with a known standard determined through research. Uncertainty propagation will be used to determine which source of error has the greatest effect on the mean force.
Our expected range of error is 0.0005 inches in caliper bias error, 0.0118 inches precision error for length and width, and 0.0039 inches precision error for height. 1% of the load bias error will be included for the tensile tester. To minimize error, we will be printing 5 samples of each infill pattern with a total of 25 samples in order to minimize the precision uncertainty associated with each step in the process. The gaps we have identified are: the sample broke except for the top layer. This is not an issue as we will just record the point at which the sample splits apart as the break point. At the time of our first trial, the tensile tester was not recording data. This will be addressed with the help of the TAs to ensure that the equipment is functioning properly.